Okay, so selecting the correct raceway depends on three things. Well, first, how many wires are going in the pipe? That makes sense. The area, like the cross-sectional area of the conductor. And I don't know if anyone's ever told you this, 10C is for conductors, solid conductors, 14, 12, and 10. So the largest size solid conductor is a number 10. 10A is for stranded conductors. And the last one is like, what table do I have to go to, like for fill, like raceway fill, like 40% raceway fill is the most common when you have 3 or more. Okay, so rigid metal conduit and flexible metal conduit. Rigid metal conduit is the one that has the heaviest degree of protection for the conductors. And it comes in either steel and aluminum, and this needs to be threaded. In some cases, I heard that they make these non-threaded couplings. I've never seen them. I don't know if you've ever seen any non-threaded rigid couplings and connectors. I've always had to thread, you know, when I was working. All right, so let's do an example. What is the minimum size rigid metal conduit that would be required to install 9 number 12 T90 nylons, so nylon stranded copper conductors? So now you know why I have to put the word stranded there, because if I don't, then you don't know, is it solid or is it stranded? Is it 10A or is it 10C, right? So here's a diagram. I like to draw a diagram. Red, black, blue, red, black, blue, red, black, blue. I got 9 of them, number 12s. In a rigid metal pipe, what would be the minimum size conduit? So first thing I'm going to do, I go to 10A and I look up a number 12, and I got to find T90 somewhere, T90 nylon, right here. See that? T90 nylon. So now it's very important that you find the area of the conductor first, the area, not the diameter, the area. So that's the first thing. I find the area of one conductor. There's 9 of them in there. So I got to take 9 times 8.47 millimeters squared. I get 76.23 millimeters squared. Okay, so now that I know the area, I got to know what percent fill. So now from 10A, I'm going to go to table 8. And this one here, this pipe has 9 wires in it. Some over 4, not lead sheet. Okay, not lead sheet, right? This one here is kind of put an X through it. They might still be out there, but I'm not running it anymore, like lead sheet conductors. So I got 40%. Okay, so now I have to go to the table for 40%. If you got the 2021, they've done an incredible job. I got to admit, this is one of the tables I like now. Where this one here, look at this, table 9G. And when I go to 9G, it's got, this whole table is 40%. 9G and H is all 40%. And now I have to just look at the column and say, okay, this one's rigid metal. This one's flexible metal. This one's rigid PVC conduit. This is like DB2, duct bank stuff. This one's metallic liquid type flex, non-metallic liquid type flex. That's the one it's flexible, but it's non-metallic. The one that breaks really easy when it's cold. And it's got the like fancy looking little gray connectors that you screw in. I got pictures coming up. Then you got electrical metallic tubing. That's a popular one, right? And then electrical non-metallic tubing, ENT. That's the corrugated stuff. This is beautiful. I got to admit, like what they've done for this table and table 19, like table 19 is beautiful. It's so friendly. You just got to get confident using it. Okay, so we have rigid metal. So I'm going to go to this right here, rigid metal. 40%. Area. Don't go by millimeter internal diameter. We're going area. 40%. Right? And I got to find something greater than or the same as 76.23. So I follow this down. Well, it's the very first one. It's a 16 trade size. Okay, now we're with PVC. So these fittings are glued together with solvent cement. Most commonly used in poured concrete, wet location, underground. One thing you got to remember is that PVC expands and contracts 5 times more than steel. And then there's this one here that just came in. See that one? That's one of the top 10 defects. You know, when you're transferring steel to PVC, so you're coming underground and you're coming up the wall, and then you want to go with steel the rest of the way, you know, maybe for protection, rigid or whatever. So they want you to use this FA, female adapter. It's got a threaded hub, and then it's got a smooth throat to glue into the PVC. So anytime you're going from PVC to steel, the steel has to be on the inside. So let me ask you something. I don't know if you can see this. Hold on. Let me do this. So this right here, see that? So I should have asked you this first. Like, here's like a threaded coupling, rigid coupling, okay? And here's like my TA. If I screw this into here, looks nice, right? Come back in a year or two, this will be cracked. If it's outdoor, it'll be cracked. Like it won't. There's no way it'll make it. It'll crack. So the right way to do it is to, you know, put this female adapter. Top 10 defect. People run like PVC underground and then they run steel pipe up a wall or something like that. They forget to put this piece here. Okay, so let's do a PVC. Let's see how you do with this one. The minimum size rigid PVC conduit that would be required to feed, it's a 400 amp, 3-phase, 4-wire service. In the conduit, it contains 4 number 600 kc mil, RW90, 600 volt, unjacketed copper. Okay, so the first thing I got to do here is I got to go to 10A. I go to 10A. Don't worry about the stranded because stranded only applies to 14, 12, and 10. But now we're into the big, these conductors. Anything number 8 and larger is pretty much stranded. Okay, so I got 4 number 600s. So I got to get the area of 1. I got to get the area of 1. And this one here, it's got, it's got an RW90. It's got an unjacketed. You notice that there's 2 600 volt columns here. And they both have like RW90 XLPE. But there's 2 different insulations, right? I got to go down to the bottom of table 10A. It might be on the next page. When you see an asterisk, it's unjacketed. When you see a plus sign, it's jacketed. So I actually had somebody, one of that I had way back 3-4 years ago, was asking me, is unjacketed bare? No. And unjacketed still has a jacket on it, but it's not protected like a jacketed cable. So unjacketed would be like a thinner jacket. And the jacketed one, you can see how much thicker it is. See, like you're going from 561 all the way to 708. That's huge. Okay. So I find the area of 1 600 kc mil, right? And remember, the asterisk means unjacketed. And like someone posted, 2246.8. Yeah. Okay. So now I have that. Now I go to table 8. Table 8's kind of a waste of time, right? You know, when you know it's 3 or more, like take a look, table 8, 3 or more, it's 40% fill. Okay, when you got 2 or more, 3 or more. It's 3 or more, it's 40% fill. So now I'm going to go to 9G. Again, it's on table 9G. We haven't even gone to H. I've got to look up PVC right here. I got the 40% column. Follow it down till I find something greater than 2246. 91 is my trade size. Okay, next. Flexible metal conduit. Like liquid type flexible metal. So flexible metal conduit and liquid type flexible metal conduit. So it's similar to armor, but the electrician has to install the conductors. We have to install it. Flexible metal is commonly used where there's equipment that vibrates, like motors, like air conditioners or motors. So remember, one thing you got to remember is where you use this type of flexible, where the electrician's inserting the conductors, you have to provide a bonding conductor based on the overcurrent device. And then there's electrical non-metallic tubing, ENT, and a lot of you call it core line, right? The corrugated stuff. It can be easily bent. It coils, like you get long rolls of it. If it's used in building walls encased in concrete, you can actually bury this directly in the earth. But one thing they don't like is that when you bring it above, you know, when there's that transition from underground up the wall, you can't. Like it's got to be protected in the rigid PVC. So it comes in various colors. And the color coding's good because I can say, oh, red is for the fire alarm. You know, blue could be for my phones and stuff. So ENT is a very thin jacket, okay? So it's not mechanically protected like rigid PVC. Okay, so now with this example, I'm putting some 14 gauge in there, and I'm putting in some number 12s. Let me go to the board on this one. Okay, so the first thing we got to do, we got to go to table 10A. So you got to help me out here. I need the area of a number 14 T90. First thing. If you participate, you're going to do well with this. Okay. So my area is 6.18 millimeters squared. See if you can find that. Don't be just satisfied with somebody else doing the work. You know? Then I got to find the area of the number 12, T90. All right, so I'm on table 10A. It's the same on the 2018 and the 2021. Same, nothing's changed there. 8.47 millimeters squared. Okay. So I got those two now. Now I just got to multiply it by how many wires are there. I got to multiply this by, there's 6 and 1. So even though this is they're 14 T90s, even though it's got a bonding, don't matter. There's still 7 of them. And then I got 6 of these. Okay. Let me see if my calculator is working tonight. 56, carry the 5, 26, 56, 5, well, 1, 42, 43. 42, carry the 4 is 24, 28. No, yeah, 42. 42, carry the 4 is 24, 28, carry the 2, 48, 50. How's that look? I don't know. Okay, thanks for holding back. Now I got to get my total area. 94.08. Yeah, it looks good. Yeah. So now I got my total area of all these different wires that are in here. Okay, so then I go to table 8. how many we got lots? 4 or more, 40% fill. Done. Okay, so it's 40% fill. Okay, when the 2021, this one's nice. I don't even know where that is in the 2018. But in the 2021, I'm going to go to table 9G. Okay, table 9G. I've got to look for electrical, non-metallic tubing. Okay, and so when I get there, 40% area, and then I got to find something on, so it's on that table, I got to find something greater than this, 94.08. Okay, 21 trade size. So from table 9G, whatever that is, I got to find something greater than 94.08 mil. So I just follow it down until I find something greater or equal to that, and then I get a lot of 21 trade size. And that's how it's done. Really. I'll show you there's one that's coming up that's it's probably the hardest one. It's when you're asked, how many number 10s can I put in a 53 trade size pipe, T90s? Those are the harder questions. Okay, so let's go back to the PowerPoint. So 10A, find the area of your number 12 and your number 14s. Multiply it out by the number of conductors there are of the same. 9408, yeah. I go to table 8, again, kind of a waste of time, like anything 3 or more inside of a pipe is 40% fill. Go to 9G. I'm looking up PVC. No, I'm looking up ENT, electrical non-metallic tubing is the one on the end here. You see how nicely set up it is? 40% fill, follow it down. Something greater than 9408, I got to go to the 221.43, which again, yeah, 21 trade size. Okay. Not too bad. You just got to get confidence with doing these more. The more you do, the better you get. People will be calling you how to do pipe sizing. Not that bad. Electrical metallic tubing. It's a thin wall raceway. This is not to be threaded. Tubing sections are joined together through either boxes or using couplings and connectors. Are connected together and connected to boxes using couplings and connectors. I know we don't use couplings to connect the boxes, but you know what I mean. It can be used in a damp, dry. Did you know you can use it in a wet location now? Because everybody was doing it. So they said, because everybody's doing it, everybody sees everybody doing it. Let's just say we can use it, provided that they use these rain-tight connectors, these ones. So EMT in a wet location requires an approved fitting for installation outdoors and must include a bonding conductor. There are several types of fittings that are available. Set screws, compression style, steel, cast. They make so many different types. How many maximum? Okay, here we go. This is the one I was telling you about that's probably the hardest one to do. Okay, so this question is asking, how many number 10s maximum stranded copper conductors are permitted in a 21 trade size EMT? For the purposes of raceway fill, let's consider that there's got to be at least 3 or more conductors installed in the raceway. Remember what I told you, that when I run a pipe, I want to run like at least 3 or 4 in there or more if I have to. Some cases you don't, but it's okay. And I want to take a full advantage of it. Let's do this one on the board too then. They want to know how many number 10 TW75s Okay, so we got a verification. 8. Okay, so we'll stop. Could I put in a 21 trade size? So this is a 21 trade size. EMT. That's good. If you can do this, then the project we're going to do later, you're going to have a good understanding. Okay, so the first thing, you know, there's not even the first thing. I'm just saying I would go to table 10A first. I'd look up the area of a number 10 TW75. What is it? 1363? 13, or no, I'm thinking T90 maybe. What's size? 1567? So on table 10A, then number 10 TW75, 1567. Okay. All right, and then the next thing I would do is I would go to table 9G, and I'd have to get the area of a 21 trade size EMT, the area at 40%. At, yes, at 40%. 132 millimeters squared. Okay. Therefore, so now finger conduit, so let's put pipe size area divided by the conductor area. In this case, we got a 21 trade size, which is 132. And I got my conductor area is 1567. So all I'm going to do is divide the area of the pipe that you're using. This one here is a 21 trade size, and this is my number 10 TW75, and that's going to equal a certain number, I guess 8.8 or something. I guess 8 point something. And so who, you know, the point something, we can't put point something of a conductor in a pipe. So therefore, 8 number 10 TW75s will fit in a 21 trade size EMT. So there, so that's another way to do it. So you can use the code book for any pipe size with any wire and figure out what's the maximum you can put in there. Okay. Let's go back here. So first thing I'm going to do is 10A. That's the first thing I did anyway. You can do it multiple ways. 1567. 40% fill. Remember, because I'm assuming that we're going to have at least 3. I had to put that in there. Then I go to 9G at the 40% fill for a 21 trade size is 132.03. And take the area of the pipe divided by the area of the wire is 8.426, round down. Remember, because you can't put like 0.426 of a conductor in a raceway, so I'm going to go to 8. So therefore, maximum number of 10s in a 21 trade size is 8. Yeah, good.